So, welcome everybody. I hope you enjoyed or still enjoying your ice cream. We have Carl and Thomas here telling us a little bit more about the numerous possibilities to escalate privileges in the cloud and to laterally move from services. So give them a warm welcome.
Hey everybody. So can everybody hear me okay with the microphone? Awesome, good to hear. So hello and welcome to Modern Adventures in Azure Privilege Escalation. I'm Carl Fossen. A little bit of background on myself here. I'm a VP of Research at NetSpy. Do a little bit of everything over there. Primary stuff is really kind of driving new research initiatives within the company, helping do disclosures, bring new services to market, that kind of stuff. In the past, a co-author of Pen Testing Azure for Ethical Hackers. Got a whole bunch of toolkits up here if anybody wants stickers. We've got some of those. We can hand those out after the presentation here. But Thomas?
And hello, everybody. I'm Thomas. I'm a director at NetSpy. I mostly do Azure and TriID work and a little bit of Google Cloud on the side. And I was also the technical editor on the Pen Testing Azure for Ethical Hackers book.
So yes, Thomas and I have worked very closely together over the years here, and we're going to give you kind of an overview rundown of kind of escalating privileges, what you can do with different permissions, all that kind of stuff in the Azure ecosystem. So we'll start things off with more of the basics on ABAC, the Azure permission model, kind of what escalation looks like just at a high level. I assume that this is a relatively technical crowd and we won't have to do that much explanation. So sorry if that's repeat information and stuff you already know. We'll then move into initial access in Azure, kind of what that looks like. And then once we have initial access, what do we do with the permissions and privileges that we have? Starting with more of the read type permissions that you might get, and then moving into kind of the CRUD operations, or we'll call them star privileges, and doing that specifically by service where we have some examples. There are so many different services that we can't cover all of them, but we're going to highlight some particularly good ones that work well for privilege escalation. We will be wrapping things up with pivoting to on-prem and kind of going back and forth there, along with, if we have time, a little bit of persistence sprinkled in there as well. We have a new wiki that we're bringing out into the world here. We'll talk about that at the end here and then wrap things up from there. So people might be wondering, why modern privilege escalation? Well, about 6 years ago, I was supposed to be here in Heidelberg speaking at TROOPERS26 on more adventures in Azure privilege escalation. I think everybody's doing the math and figuring out that that conference didn't happen. But 6 years later here, Tom and I were talking about different ideas that we could bring for potential presentation here, and this one immediately popped back into mind. There's just been so much that's happened in those last 6 years, and revisiting the slides that I had ready for the 2020 presentation, there's just so much that we've learned from that time to now. If we just look at some of the numbers here, there's over 200 different services and products within the Azure ecosystem. That's a lot of attack surface area. Along with that, we have almost 900 built-in roles. 6 years ago, I think in the average client environment, we were seeing people maybe use 6 to 10 different built-in roles. And now we're just seeing all sorts of different roles that are being utilized. Along with that, tons of different permissions that are attached to those. So just given that wide swath of different permissions, roles, and how things have changed, we wanted to revisit this from a modern take. There's also lots of new tools. Tools that are constantly getting updated. We're not really going to be focusing on the tooling itself that's out there, but there's definitely some really good tools that are out there at the moment. We're going to be mostly focusing on the ABAC concepts and how that applies to the permissions that you might inherit from any kind of credential or identity that you get access to. And then applying these specific permissions to any attack chains, privilege escalation techniques, those kind of things from there. But before we get into those, I'll let Thomas talk about the permissions model.
Yeah, so before we go any further, we got to talk about ABAC, and specifically the Azure workload version of ABAC, right? Not necessarily the Entra ID side, because we're really going to be focusing on cloud workloads here, right? So it's who has access to what, where that who is users, groups, service principals, managed identities, right? And all these identities are going to be defined on kind of that Entra ID side of things, the identity side of things. And Azure is going to be inherently linked in that way, right? Because all of those principles are going to be defined there. They're being granted access to resources within Azure, right? And there's not really going to be that much overlap between Azure and Entra ID in terms of ABAC. So like getting the owner role in Azure does not necessarily, or it doesn't really give you anything in terms of Entra ID directly. There is a little bit of strange overlap between the two spheres, and that's with global admins and how they can elevate their access at that root tenant level, right? But besides that, there's not a whole lot going on there. So we can't really go any further as well without talking about managed identities, because this is going to be the number one thing that you're going to be kind of looking at when you're looking at Azure ABAC, looking at workloads. What are they doing? What are they accessing? Right? And these are really just service principals with the intended usage of being used with Azure workloads. And their credentials are going to be completely managed by Microsoft. Right? And in theory, you should never be able to get access to those certificates, which there's been some weird variations of that in the past, but you should never be able to see that certificate material ever, right? So within the Graph API and how Entra ID defines these things, they're going to have a service principal type of managed identity. So pretty clear in terms of when you're looking through Entra ID, what these things are and how you can identify them. And then there's system assigned versus user assigned. And just talking at a very high level, system assigned is always going to be tied to a resource, right? The lifetime is going to be defined by the lifetime of the resource. Whereas user assigned, that is its own specific type. You can assign that to many different types of resources. And then one thing with the Graph API, when you're actually looking at service principals, you can see the actual resource ID of both system assigned and user assigned in the alternative names property. And there's also a substring that's a part of that property where is explicit is usually set to true or false. And that's a good indicator. If you're looking at a user assigned managed identity, that's going to be set to true. And then we just have this slide here. You know, we want to introduce some of these concepts because these are going to be important as we move forward with Azure ABAC. Resource hierarchy and scope are going to be linked because, you know, in terms of how you're looking at Azure, you have your management groups, and then under that you have subscriptions, resource groups, and then resources. And that's important because the scope at which you assign role assignments in Azure is always going to be inherited and then cascade downwards, right, for the most part. So the scope at which you assign roles in Azure does matter quite a bit. And then when you're assigning roles, you're assigning definitions of roles, right, which are collections of permissions in JSON, built-in and custom roles that you can create with specific permissions, wildcards, things like that. Kind of touched on role assignments there. That's how the scopes and the role definitions work. And then when we get into permissions, that's going to be the more interesting part about what we're going to pick up on next, along with the control plane versus data plane permissions. So when you actually get into role assignment or role definitions into the actual JSON, which we'll have an example here in a second, everything is going to be defined with actions, right? Which is usually the provider or the resource type, and then there's an action verb. So Microsoft.keyvaults, vaults, right. That's how you make changes to key vaults, and specifically that sub kind of vault object, right? And then amongst those permissions, there is a control plane and a data plane. There's a separation here in Microsoft and Azure make this distinction where management type actions, so administrative type actions, changing, you know, permissions or role assignments, those are all going to be contained within the control plane. Whereas data actions, where say we're accessing a key vault secret, those are going to be defined and allowed via data permissions or the data plane, right? So this is kind of an example of, you know, the specific permissions and the difference between the control plane and then the data plane, right? And one interesting thing about Azure is that you can have wildcards either at the base here, and this is the, I believe this is the owner role here, yeah, which is the most privileged role in Azure ABAC. So you have the wildcard there, and then you also have your not actions, data actions, and not data actions here. So just something interesting to think about when we're starting to talk about how permissions work within Azure. But we said we were going to talk about modern ABAC, right? And we can't also discuss modern RBAC without talking about attribute-based access control. Not a new concept. It's been around for a little while, but we're starting to see it more and more frequently, not only in a lot of environments that we look at, but also Microsoft themselves are using ABAC quite heavily when they're looking at role definitions. Right? So ABAC is based upon the attributes of either a request, an object, an action, the caller. It's basically a way that you can combine this with RBAC to further constrain roles, right, or role assignments. So there's a nice Microsoft diagram here that kind of shows what that constrained delegation looks like. If you apply an ABAC condition to somebody that has the permissions to grant out roles, you can constrain exactly what they're allowed to hand out to people, right? So constrained delegation, it's an interesting and kind of new concept. Well, not new, but in Azure RBAC, it is relatively new. And we really only saw this before with storage accounts and now with role definitions. And the way in which you apply ABAC is through something called conditions, which is made up of actions, expressions, attributes. And the format is a little unique, to say the least. So if this is your first time looking at ABAC conditions, this is extremely overwhelming, right? So I had a lot of trouble at first looking at this because you'll notice that the format is a little bit different. It's not a recognizable, it's not JSON, right? And it's a little strange, but we're going to break it down for you. And this is pretty printed so you can kind of understand what this ABAC condition is doing. And this is taken basically from the Key Vault Data Access Administrator role, which is a predefined or built-in role that Microsoft has. And basically what it does is it's trying to attempt to constrain the roles that this role can assign to people, right? So part of the definition of this role is it is allowed to write role assignments in the environment, and this is trying to lock that down. So when we look at this, there are a couple of things you want to see here. This is a condition, and ABAC conditions can have multiple conditions. So this is also the secondary condition right here. And conditions are made up of two things, actions and expressions. Actions are those things that are the things that the caller is trying to do. So in this case, if the caller is trying to write a role assignment or create a new role assignment, this is the action that would then match. And then the expression would kick in to validate the actual expression condition here, which evaluates to true or false. And if it evaluates to true, then the role assignment right is basically allowed to proceed. So we kind of talked about what this roughly translates to, right? That action there is the thing that triggers the expression, and if the expression evaluates to true, it's allowed to go, else it's not. And then to put it in the most simplest terms, basically this is constraining what roles can be given out if someone is granted this specific role definition. So this is an interesting thing because there's a lot of ways, when you're reviewing this, there's a lot of ways you can make mistakes, right? So the first thing that you have to think about when you're looking at assigning ABAC and looking at these conditions is what is the actual role definition or the role assignment you're trying to add ABAC to, because that's very much going to affect what the role can do. And when we looked at this before, basically part of this expression is it's trying to match on a very specific set of GUIDs or role definitions that it's allowed to grant out, which is a good way of doing things as opposed to here where Microsoft says, ooh, you might want to be careful with that because if you're using an explicit list of roles and there's a new role that comes out that's extremely highly privileged, all of a sudden this ABAC condition does not protect you in the way that you think it will. Right? So this is somewhere where, the way in which you construct your conditions does matter, right? And then there's a note on Graph API permissions here. This is just taking another left turn to introduce this concept. But when we're looking at Azure RBAC, what we see a lot in environments is that people love granting out Graph API permissions, and specifically application permissions. There was a great talk yesterday from Sapir and Shahar. Go watch that. They do a good job of outlining how this can be abused. But in Azure, where we see this the most is really with service principals and with managed identities. So whenever there's a weird cross-section between Azure and Entra, say an admin is trying to automate some sort of user provisioning, they like to do that either within Logic App Flows or in automation accounts. So if you can get access to an automation account, there is a good chance that you should also be checking against Entra to see, are there role assignments? Are there application permissions that you can abuse here to jump from Azure to Entra, So just wanted to mention that one. And also, there's a really cool resource from Merrill in the community who is no longer at Microsoft, but he has a great graph permissions mapper where you can basically specify a permission that you're looking at, and then it'll map it to the graph API endpoint that, in theory, you should be able to call. So a really cool resource if you've never looked at that before. Okay, well then that gets us into the escalation theory of things. So we kind of discussed permissions, ABAC, and now we're going to start talking about the different categories of privilege escalation that we're seeing in Azure, right? And a lot of this isn't going to be new or groundbreaking, but we wanted to kind of categorize it by permission, which is kind of the way that we're thinking about things. So you have direct escalation, and that's the most brutally simple kind of escalation that you can have. You basically have the permissions you need to have admin access on the environment. So role assignments right is probably the easiest example of that, but there is also the role definitions right, where you can actually modify, create new custom roles. And since wildcards are a thing in Azure, you can create custom roles that are basically equivalents of owners, right? So there's a lot you can do with custom roles when you're in an environment as well. And then the next two are pretty related. They deal with execution and managed identity access, and then user-assigned managed identity access. The first one there relates to how do I get command execution in a service? So virtual machines, app services, function apps, things like that. Because if you can get a command execution in one of those services and you can hit the IMDS, then you can control the managed identity that's attached, right? Whether that's system assigned or user assigned. The next one is more akin to what you would know in AWS as like a pass role operation, where if I can assign a user-assigned identity to a resource that I control, like a virtual machine, then I can get access to those permissions. So if you can assign user-assigned managed identities, that's also very powerful if they're highly privileged. Then there's indirect escalation, which we kind of say is like something like secrets access, as an example. So getting access to storage account access keys, or getting access to function app access keys to then do supply chain attacks, or to modify code, or do something like that. And then dependent service control, this is a little bit of a weird one, but we're seeing this more and more, where as Azure has more managed services, such as function apps, or if you've dug around in the AI Foundry, there's going to be things like machine learning workspaces and things like that. The code for all of those things are actually stored in managed storage accounts in your environment. So if you can get access to storage accounts, and if you can start overwriting code in those storage accounts, you can then affect the primary service, which is like a function app, or like a Jupyter notebook or something like that, to then get access to further permissions, data, or things like that within the primary service. So just a few things to think about there. And we kind of touched on this one slightly with permissions, but when you start looking at things from the lens of permissions, this gives you a lot more robust coverage for privilege escalation mapping, right? Like there are 897 built-in roles in Azure right now, and that's a lot of roles. And some of these roles are not clearly defined in terms of one job function, right? There are some roles where you need different permissions across different services, and then that's where things start to come into play, where you can start mapping out these vectors, right? So we went through, we tried to identify as many as we could across what we define as like 21 core services, and we came up with a pretty strange list of permissions, right? How Azure does permissions in ABAC is pretty interesting. And the other thing that we noticed with Azure built-in roles is Microsoft is now starting to use ABAC conditions a lot more than they used to. So they have a lot of roles that actually have role assignments right, but they have that ABAC condition, which then constrains the delegation. So in the other example where we had Key Vault Data Access Administrator, you don't just become owner because there's that ABAC condition that's going to stop you from arbitrarily assigning roles, right? So that takes us then to, well, how do we gather these things? How do we map these things out? And pre-AI, pre-Claude, I actually started doing this a few years ago, and it was a lot of work. I had to look at role definitions. I had to review actions versus data actions. I had to resolve not actions and things like that. And I was like, okay, this is fine, until I found an undocumented version of a known API just by proxying around the Azure portal. And basically what you can do with this API is if you give it one or many permissions, it will try to find every single role definition that it knows of that has those roles contained. So it's going to evaluate not actions for you. It'll evaluate wildcards and things like that, which is really useful. And it also covers custom roles as well, too. It does some weird stuff with data actions that you have to handle, but because it's undocumented, like I'm not gonna hold it to too much, so just know that if you're ever going to use this. So the idea was, if we have this list of permissions that's interesting to us, we can then take those and start building out maps between permissions to roles, right? So this is just an example of that API, and it's the role definitions list ARM API, right? It's nothing crazy, but the version is technically not documented, and I've only ever seen it in the Azure portal. So if you provide a permission to the has all permissions filter, you can then get a list of all of the roles that contain that permission. So what are we going to do from here? We have this list of permissions. We have an API that's going to help us resolve some of these things. Let's take some interesting permissions and see where they show up, right? So for example, storage accounts list keys action. So with this, we know that this is the permission that allows us to get access to shared access keys in storage accounts. And the weird thing about shared access keys is that they give you that full access to the data plane, read, write, delete amongst container, blob images, or blobs and file storage and things like that. This is technically a control plane permission, but it can affect the data plane. So it kind of fits into those categories that we were talking about before, where having access to a local service secret then kind of starts to give you further and further privileges, which you can leverage into dependent services or just having full admin access to that service. So when we resolve this, we found it in 22 built-in roles. Owner and contributor, we do expect that because, again, they have star permissions, but there's a lot of other roles that aren't documented specifically in Microsoft's documentation, and some things that you might not expect to show up in here, right? So Azure AI Administrator, Log Analytics Contributor, and Virtual Machine Contributor all have this permission within their role definition. So now when we start thinking about this, the scope at which you start to assign things and whether you are segmenting your workloads out correctly into designated subscriptions, that's all going to start mattering if we now have more and more roles in Azure that kind of start bleeding into the next, right?
I think what we see from a role application perspective is typically more at the subscription level as compared to, say, a management group level. So when you apply one of these roles at the subscription level, you may be thinking, oh yeah, the AI administrator probably needs access to all the AI workspaces within this subscription. Yeah, let's give that at the subscription level. But then that also enables the storage account list keys out for all of the storage accounts that are in that same subscription. Now, good hygiene with your resources and separation of duties, all that kind of stuff can help solve a lot of that. But that's not what we see in a lot of practice. In practice, there's just a lot of overlapping services and different use cases, deployments, all that kind of stuff in the same subscription. And that's where these kind of things can become a problem. So just starting with a little bit more of what the escalation theory is in practice here, getting initial access to one of those roles that we talked about, or to any kind of identity, credential, security principle, whatever. We have our initial access into the Azure environment. At that point, we typically check our role assignments, see what we have for an Azure Resources and Enter ID roles perspective. If it accomplishes the goal that we're going for, getting access to the key vault, the storage account, whatever, global admin, then cool, we're up to an elevated role. If that's not working out, let's use the existing role assignments to then pivot to other resources in the current environment, maybe move over to different subscriptions that this specific identity has access to, and kind of keep looking for other credentials, other identities that we can take advantage of to keep going through this process. The thing that we really want to highlight here is that this is not really a linear path. Most of the time, we're bouncing from resource to resource, trying to find the thing that will help us elevate. Now, being able to dump the permissions for all of the subscriptions, we're often given the reader role on a subscription or a set of subscriptions that we're reviewing. We can already see who the privileged users are and kind of target those ones. But if you're in more of a red team situation, sometimes you're feeling things out and you maybe don't want to dump all of the role assignments for the subscription because it might be a little bit noisy and you want to be a little bit careful with that. So like I said, it's not typically a linear path. In the case that we put up here, let's say that you have VM contributor. Let's say that there's a domain controller that happens to be a VM in your Azure environment. That's actually pretty common. People like to back up their domain controllers to the cloud because it's safe up there, and resilience, all that kind of stuff. But if someone has write permissions or contributor, whatever you want to say, over that domain controller, you have system-level command execution on that. We'll cover that in a little bit. That effectively is domain admin. So you get command execution of system on the DC. Let's say that there's some kind of on-prem connection that gets us back down to the on-prem environment, maybe through the VM itself, and then we find cloud admin creds down on on-prem, escalate up to enter admin, then we're all the way back up to the cloud again, but this time we've escalated privileges. That's just one more kind of infrastructure-based option. There's all sorts of different paths, services that we run into where we're bouncing from different services, working on an escalation, trying to get a little bit more access. So from an initial access perspective, we're not going to spend a lot of time on this. Fairly technical crowd here. We don't have to talk about entry points all that much here. But we are still seeing some success with password attacks, with things like MFA and conditional access. That is causing some more problems for us from entry ID credentials and all of that kind of attack surface. But public credentials, finding storage account keys like Thomas was talking about, finding those in public sources has actually been pretty lucrative. We can get into initial access for a storage account there and start potentially pivoting from there. Application vulnerabilities are actually pretty common for us on the NetSpy side. We do lots of web app testing, and we have consultants that pop over to the cloud side and say, hey, we got command execution in an Azure environment. Anybody want to help us pull apart the Azure side of it? And we get to dive into those, which can be a lot of fun. I did call out SSRF on here. That seems to be a thing that plagues the cloud. If you look at older AWS, GCP, some other clouds as well. One of the most canonical examples of getting access to identities tied to specific resources is SSRF to get to the IMDS. The metadata service, you get access to temporary credentials from there. From the Azure side, they actually require specific headers on the IMDS, so that kind of limits your ability to do things like SSRF to get tokens back. Doesn't mean we can't make use of the IMDS to get tokens, but we'll save that for another slide. General token gathering, doing things like device code phishing, access token theft. We're seeing a fair amount of success from like a red team perspective there. That's more of a modern technique that really wasn't happening as much 6 years ago when we kind of gave the initial version of this presentation. And then the last thing I'll call out on here is resource enumeration on the internet and then tying that back to tenant IDs. This is kind of a shameless plug for a tool that Thomas and I put out back around DEF CON last year called A-Team. And what that does is it identifies Azure resources based off of subdomains. So Azure has standard subdomains that they use for hosting host names for the resources. And we found different ways that we could coax the resources into giving their tenant IDs back, basically with HTTP OAuth requests, and then tying those tenant IDs back to the proper name of the tenant, and then mapping out all of those resources. So we can enumerate those and then use some of these other attacks here to get into those resources and know that they're specifically on the target that we want to go after. We're not just randomly attacking stuff out in the cloud. So I mentioned token stuff here. I don't think we need to do a full token primer or anything like that. Dirkjan's here, you can ask him. But yeah, I think that kind of covers it for initial access. So once we do have initial access into an environment, the most common thing we do is say, okay, well, what do we have here? What kind of permissions do we have? From the easiest, just simplest thing, if you have, say, username and password or some kind of active web session for single sign-on, anything like that, the Azure portal, you can go up to subscriptions, enter ID, any of those menus will help you find those pretty easily, but that's not always an option. More often than not, we'll have, say, app registration credentials that we're authenticating with, and you can't get up into the Azure portal with those, so that's not super helpful. Using things like the AZ CLI, AZ PowerShell, any of the REST APIs, we have some collection scripts within the Microburst toolkit that we've written that help gather all of that stuff. But that's also pretty noisy. If you want to be a little bit more surgical, there are specific ways you can pull your own specific role assignments and all that kind of stuff. I would recommend going more that route if you want to be a little bit more stealth on that. Do you want to cover the last bullet there?
Yeah, and this one's a little bit weird because not every built-in role will always allow you to list role assignments arbitrarily. So if you can combine this with OAuth, with compromised credential, whatever it may be, and you know resource IDs, you can start brute forcing those against this API to return what permissions you might have on that resource, right? So that's one way to get access to permissions without having just blatant role assignments list.
And then last bullet here, nothing showing here with any of these role assignment things means that you likely don't have any role assignments in any of the subscriptions, but chances are you have the ability to read Entra ID depending on what kind of credential you have, and you can then dump Entra ID data from there and try and use that to pivot, bring it back to your password attacks, anything like that from there. All right, so that's pretty much like our basics out of the way here. Let's get into the actual attacks that we can do once we have specific privileges. So starting with more of the read-based permissions, our primary goals here, and we kind of talked about these a little bit, are enumerate available resources within the subscription. That is attack surface area that is outside of the Azure control plane, but let's say there's an app services app that you want to go after. Maybe that's a good target that you can enumerate with those read permissions. Finding secrets, keys. One of the things we've had really good luck with is SAS tokens. If people are not familiar with those are shared access signatures that are tied to storage accounts. So let's say that you want to give temporary access to a PDF that's out in a storage account. You can generate a SAS token for that, give that URL, that times out over time. You can set specific permissions around that. We see those very frequently misconfigured to give excessive permissions, to do directory listings, like 100-year timeouts. They're basically not expiring. It's super common to find those. We'll actually talk about some examples in just a minute of that. Additional configurations and potentially files, depending on the service type, can expose additional credentials, and we start going through this loop again. Not a real policy, just wanted to give some kind of example read kind of actions or data actions on here as well. Here is a real role definition here for the reader role. And wanted to share this one here. It's got star in front of read, meaning you have star, all of the resources you have read on, which, as we're going to see here, gives us some different options to potentially extract sensitive information that maybe got into some of the configurations or found its way into the environment. But I'd say most commonly on our Azure Cloud Pen Test, this is the permission we're starting out with, partly just to do configuration auditing, kind of see what's going on there. So first thing that we'll cover here is virtual machine extension configurations. When you have a virtual machine, you may want to specifically configure it. You would most likely do that with an extension, unless you're using pre-baked images or anything like that. And with those extensions, you push a configuration, and that can be read with just read permissions on the extensions. We often find sensitive data in those extension parameters. Good example that I found in a real client environment, somebody was installing CrowdStrike on every VM that they were spinning up in their Azure environment, and they used the SAS token that we were just talking about. Now that SAS token gave me read, write, list, pretty much everything on that storage account, and it wasn't really expiring, so we had full control over the CrowdStrike install process. We could modify the PowerShell script that was being brought in to do the actual install on the VM extension as it was coming up online, and we effectively could have taken over all future builds in that Azure environment. So that was fun. Definitely something to look out for, though. See lots of good stuff there. Deployment templates. When you deploy a resource out to Azure, in the resource group itself, it creates something called a deployment. Those have templates associated with them, ARM, bicep, pick your poison there. I know people have preferences either way. But what you can do with those deployments is actually export all of the parameters related to the deployment and the templates, the associated ones. And we often find, particularly in older deployments, people seem to get more on top of using the secure string flag, but we'll see clear text strings for things like local admin passwords or other service principal credentials, whatever, that get put into the deployment itself just as clear text strings. I have a theory, and I haven't seen it proven yet, but given all of the AI elements with deployments and building up environments, I think that we might be seeing more of this again. You never know, but I've just had enough headaches with trying to automate some of these things with LLMs that wouldn't be surprised if a string sneaks in there where we need a secure string. So something to look out for. Oh, and I was going to call out the permissions box here as well. Sorry, we do have our required permissions here. Generally, these are just going to be permissions that relate to the different attacks that we have on here. These aren't like a one-for-one, like both of these things require both things. In this case, resources deployments read, ties to the templates, the VM extensions read above that. So these are just kind of helpful reminders to tie things back to the permissions. Other interesting kind of read things that we can dig into from an automation account perspective. For those that are not familiar with automation accounts, it's a way to do serverless code up in Azure. Personal favorite of mine, I did a whole presentation on it. I love this service. There's so much fun stuff in it. But we'll condense it down into the runbook code itself and parameters. The code, take a quick show of hands here. Anybody hard code a credential into their code ever? I'm holding my hand up. I've done it. I'll admit to it. I delete it right away. It's just a proof of concept thing. Yeah, this happens all the time in actual live environments. We can read that runbook code with these read permissions, and you've got your hard-coded credentials right there. Parameters are not meant to be used for credentials, but we often see the runbook parameters being used to store credentials, API keys, things like that. And then when you run these runbooks, you get jobs, and those jobs have outputs. We can see in the screenshot right here that we have some interesting information here. I'll see if the zoom works. Hey, look at that. This is actually an example from a blog post that I've got the title off to the right here that came from one of our consultants at NetSpy, Joshua Morell. But we can see that outputting sensitive data into the job outputs is cool for everybody. In this case, it was actually Microsoft that did this. They have the Azure Site Recovery Services service, kind of a weird one, but to manage the sites that you're recovering, they have an automation account, and this has since been remediated. Josh disclosed this like 2 years ago now, but in the output here, it was actually outputting full access tokens for the managed identity that was tied to the automation account. So we're actually able to elevate to that, which I think was contributor and a subscription. Yeah, which is something to kind of keep in mind with these things. Often with automation accounts, you start with contributor on the whole subscription. It's kind of a carryover from run as accounts, but I'm not going to turn this into an automation account presentation. So last thing that we'll cover here from a read perspective, before we touch on data actions for that, is container registries. So as a reader, you can pull container images. Those often have sensitive information in this. This is one of those weird ones where it kind of feels like it breaks the data plane, control plane kind of thing, but if you have read on the container registry, you can get access to the image, authenticate to Docker, and run the images yourself locally, things like environmental variables and just local files on the containers themselves. That's a gold mine. We often find credentials all over the place in those. Okay, we won't linger on this one. This is just an example, storage blob data reader that has data actions and actions on that. And then we'll touch on storage accounts related to this. Yeah, with the control plane and data plane sides of things, if they're read permissions, we can list out the containers in the storage account and potentially read the file contents. That's really handy if you just have the ability to read the storage accounts and list the available containers and what their permissions are. We're overloading the term container here multiple times. In this case, it relates to storage account folders. We'll just simplify that. And if it's container permissions, it does directory listing, and you can list all these things out. So while you may not have the data plane permissions to actually read the file, if it's a container permission container, you still can actually just use a web browser and list out the available files from there. So kind of convenient. We have a whole bunch of other ones that we just don't have time for, but we wanted to include them in a slide. So if anybody wants to dive deeper into those are good targets for this as well. Moving on to more of the, we're calling them star privileges, kind of the CRUD type privileges. It's all more of the same, except in this case, we are going to be dealing with command execution. As Thomas was talking about, the kind of dependent services, getting the command execution through those, as well as virtual machines, which we'll touch on first. So escalating on virtual machines themselves, as previously mentioned, oftentimes virtual machines have managed identities associated with them. We want to get access to those managed identities or anything that might be on the virtual machines themselves. Conveniently, Microsoft gives us at least 5 different ways to do command execution as a service on the virtual machines. All of these run as system or root on the virtual machine itself, so it's instant admin on the virtual machine, which if you're properly segmenting everything, this is fine. However, if you inadvertently get access to these kind of things, it's an easy way to escalate and kind of complicates that whole model like we talked about with the domain controller. You may not be domain admin on an on-prem environment, but if you have right over a virtual machine that is a domain controller, you're basically domain admin. So you can just do your totally normal Windows stuff commands to run and go from there. One of the things that you can run as a totally normal Windows command is querying the IMDS. This is how we get tokens for the managed identity. It's just that 169.254, pretty standard IMDS address there. One of the ones that I personally like is the wire server service. It's kind of an orchestration harness for VM deployment. It's publicly available IP that's only available through Microsoft services, and you also have to be a local admin in order to query it. There's a whole encryption, decryption process of how the wire server service gets things like VM extension data onto the virtual machine. We've got a blog about it on the NetSpy website, but it's a fun process because if you decrypt those VM extension configs, there can be interesting things, even more than what we can see as a reader. If you want to do this directly off of disk, sometimes there's a little bit of drift between what gets deployed on the wire server service and in the actual files that are running on the virtual machine. But we have a tool within Microburst written by Jake Carnes that goes through and reads all of the available files for the deployed VM extensions and decrypts them with a cert that's local on the system. It doesn't always totally work. Sometimes those certs disappear over time or things kind of age out on that, and you can't read everything. But we've found that to be really, really handy, particularly with seeing what run command commands are being run on the virtual machines themselves. I've seen domain join operations happen and clear text credentials being fed in through VM run command, which is super helpful for us because those happen to be domain admin, and it was really convenient. So definitely something to look out for. But again, this requires local admin, and yeah, we've got some PowerShell that automates that whole process. How are we on time? Good? Okay, cool. Just double checking. Let's see here. So one thing related to virtual machines we wanted to call out here in kind of that excessive permissions that you wouldn't expect to happen that Thomas was talking about earlier, the log analytics contributor role. Reading the name of it here, you might think, okay, well, you manage log analytics. That's kind of boring. It's the logs and it's going to a log analytics workspace. There's not a whole lot going on there. But that specific role actually has VM extensions permissions, and we just talked about those a little bit. That's a way that we can do command execution. That's the classic compute. We have also hybrid compute, and I think regular compute just above that. So that means that you can write extensions that can do command execution on the virtual machines themselves. This has storage account list keys action as well. This is relatively highly privileged, and we've been able to make use of it during pen tests in the past to escalate and move onto different resources within an Azure environment. So moving on to storage accounts and how that relates to more of these star permissions. Yeah, we can access sensitive data in files, all that kind of stuff. That's really easy and nice. We do find lots of good data living in storage accounts. On top of that, we can list out the keys and get more of the persistence on that. The key-based access, they are keys that you can roll and get those changed out if they do get compromised, but dumping the keys for the storage accounts and going in later to kind of pilfer any data in there is pretty handy. There's also permission-based access that we talked about on the data plane side of things. We won't belabor that point. And then we've got a screenshot here for what that SAS token creation looks like. You can scope it to different services within storage accounts. Storage accounts is not just blobs. You've got 4 different services underneath that, and we don't have time to dig into all of those, but there's lots of good stuff that can live in storage accounts. Definitely recommend taking a look at any files that are there, particularly as it relates to kind of cross-service command execution, or what we're calling dependent service control. Thomas and I did a presentation 2 years ago? 3 years ago. Sorry, it's been a little while. On function apps and how we can abuse the storage account access to take over function apps. This also technically applies to logic apps on the standard plan, because those are effectively function apps at their core. So what you technically do here is take over the storage account, write your own function into the function app, call the function through the function app, and then you can get managed identity tokens out. You can get persistent access into the function app. We wrote a tool to automate the whole thing. It's called Funko Pop. It's out on the NetSpy GitHub. We also have other services that relate to this. We're not going to dig into all of these, but definitely had really good luck with Cloud Shell. I think somebody recently had good luck with Data Factory. But the one we are going to touch on here is Azure Machine Learning. So as Thomas mentioned earlier, Azure Machine Learning, you've got your notebooks that live out in a storage account. We can kind of see what that looks like in the Azure Storage Explorer, as soon as I can get that here, and how it looks like in the AML Studio. So if somebody else has access to that storage account, they can take my test notebook and change the Python code that's in there and get control over that. We kind of automated that whole process to extract managed identity tokens out of the service itself. And yeah, that can be pretty handy to work with over there. All right. So as I said, we have limited time to a certain degree here. We've got a whole bunch of other things that support managed identities and token extraction. It's kind of an important thing to note here. There are a bunch of Azure services that support managed identities for the service itself, but there's no way to get command execution or any kind of coercion things to get tokens extracted for the managed identities out of the services. These are kind of the core ones that you're going to want to look at if you have any of those permissions. We don't have time to dig into all of those. If anybody wants to talk about these things, I love digging into all of these different attacks. I spent like a year writing processes for all of these different things internally here at NetSpy, so I love digging into these. We can talk after the talk, but I'm going to hand it back to Thomas.
Yeah, and this one kind of borders between persistence and just another way to query Azure SQL. So I think this has been around for maybe 4 or 5 years, but I don't know how well known it is. But you can, with Azure SQL logical databases, you can query over HTTPS. So you don't have to have like the TDS protocol. You don't have to have SQL Studio or whatever. You can just do it over the HTTP endpoint. So every logical SQL server exposes a /query endpoint as part of its like HTTP public endpoint. And basically, you can just send queries to that as long as you have authentication. So a local SQL admin, or it also supports Entra ID authentication. And this is technically a preview feature, and I don't know how long it's been in preview, quite a while. But you can access it via the portal, and that's how we first found it. And there's some weird things that you have to do to get it to work programmatically with some HMACing and things like that. But once you do have that, basically, you can run this anywhere. So I'm just using PowerShell here, but you could use Python, curl, or whatever. And then with that, you are able to get access to SQL Server just over HTTP. So this can be really useful in constrained environments where you can't actually interact over that protocol, whether that's firewall rules or other kind of constraints. But over HTTP, yeah, you can certainly do that. And this is something I'm planning to hopefully release here in the next few months. But
all right. And then kind of the last thing that we're going to cover for these star privileges here is if you want to, we'll say do this at scale and throw the entire book at the Azure environment that you're attacking here. If you have the correct permissions to dump any keys, credentials, or anything associated with a specific service, we have a tool in Microburst called getAZPasswords that targets all of these different services here. Any associated keys that are available, passwords that are going to be stored in configs, app services is a really good option for that one. It will dump those using PowerShell here. I will call out Key Vaults specifically here. The access policy model for that is going away in 2027. A little sad about that because we've made really good use of that. And GetAZ Passwords actually has configuration in it so that you can just grant yourself access to the Key Vaults in the access policy and then revert that. It's all done inline in the code there. But we'll have to rewrite that to deal with Azure ABAC now because they want to use Azure ABAC for all of that. So, like I said, if you want to do this at scale and really risk getting caught doing everything that you're doing, there's definitely detections in place for this. Maybe be a little bit more surgical, use individual parts of the code here to do that. But those are all services that we wanted to highlight that have keys associated with them that are useful for persistence and just for privilege escalation. We're going to touch very briefly here on pivoting to on-prem systems. This is a whole nother presentation in and of itself here, but we wanted to call out 3 specific services and some associated permissions with them that could allow you to pivot to an on-prem environment from the cloud. So first one would be ExpressRoute. This is effectively like a VPN from the cloud down to your on-prem. And if you're on a virtual machine that has access to an ExpressRoute, you can then pivot down onto an on-prem environment from there. Arc is another service that's available in Azure that allows you to effectively onboard other systems outside of Azure into your Azure environments. Let's say you've got a Windows system running on-prem or even in like AWS Cloud. Spun some up over there and enrolled them in Arc. You can do command execution through that, just directly through what's effectively VM run command, like we talked about before, as well as other VM extensions that you can install on the enrolled Arc system. Then the last one that we're really not going to dig into, because that is a very deep environment that we really don't have time for, is Intune. You can do command execution, and that kind of falls into the Entra, M365, Azure. It starts blending. We're going to focus primarily on Azure stuff, so we'll leave that for another one. And then wanted to wrap up here with a sample escalation path. So, just a real simple, real-world experience kind of things that we've run into. Command execution gives us access to an app services application. Say that has Enter ID authentication tied to it. That actually stores service principal credentials in the environmental variables. Let's say that the admin wants to use the same service principal for everything, so we just give them a bunch of extra additional API permissions. Or maybe they have, I guess in my example here, they have ACR permissions as well. We could get into the ACR service from there. Maybe that has additional creds, code, other things that we can make use of, and then use that to get access to additional identities, additional service principals, anything like that. I have actually found app registration credentials in an ACR image that had the app role assignment read write all. If anybody followed any of the Midnight Blizzard stuff, kind of following some of that stuff in here, definitely got to replicate that in a live environment with an actual client, and they had all the configuration kind of in place to do that. So that was convenient. Very enlightening. Time-wise, we're not going to spend a ton of time persisting in Azure here. If people want to dig into this, feel free to take a quick picture. We are going to share the slides after this. We just got to get them up into a storage account on Azure and get them shared out. But we think of persisting in Azure at both the Entra level and the resource level. I'll just focus on the resource level here, adding additional credentials to services that support it. There's a whole bunch of different services that allow you to enable credentials or add additional credentials. Azure SQL is a great example of that. Backdooring existing code bases through automation accounts, function apps, app services, anything like that, or CI/CD pipelines that might be existing in that Azure environment. And the last one I'm going to note here is exporting managed identity certificates. I don't know if it's been fixed, but API management actually had a vulnerability in the last 6 months here where you could export the managed identity certificate for the attached managed identity for the resource, which would give you persistent access for about 3 months to the managed identity that's associated with that API management service. Arc has some similar things. I covered that in a previous presentation a couple years ago, but that can definitely be good for persistence. I'm going to
Cool, yeah, and to wrap this all up and everything that we've kind of done here, from mapping permissions to vectors to things like that, we want to kind of give back to the community and hopefully work on together, right? So we're working on a security wiki here that is going to have a lot of the concepts that we just talked about. So you can go to azurepentesting.com, and currently that is just a placeholder right now, but we will get that up here shortly after this. In terms of contributing guidelines, in the age of AI, we would really love it if you wrote the content yourself if you're looking to contribute, right? We know Claude can do a lot of cool things, but we really value kind of the community contribution in your own words. So, and then just quick conclusions to wrap things up here. All of the fundamentals still apply in this day and age, right? So logically segmenting your workloads by subscription, by management group, and things like that. And hopefully with these attacks and some of the ABAC things that we've seen, where you put things, what you grant role assignments to at which level matters very much in this day and age, right? Reviewing each of those built-in roles before you assign it to understand exactly what it can do, using those tools before that we listed out to help map those attack paths, and then assigning that least privileged role to the most narrow scope possible, right? Preferring, resource group levels or specific subscriptions where things are segmented out correctly is going to be your best defense. And that's more important than ever. At Forward CloudSec North America, I think it was Kinnard McQuaid, gave a really cool talk about an AI worm that he wrote for AWS. It moved very, very quickly, and it didn't really care what it did. So as things start to get faster, these best practices will help to slow things down to a certain degree, right? And thanks to everybody here. We wanted to just call out a few researchers that have helped us, inspired us, members of the community, right? And all this research is building upon other members of the community. So we wanted to give some thanks there. And thanks to everybody here and troopers and everything else like that. So this is one of the coolest conferences I've been to, and this is my first time. And this is, it's a really cool conference. So thanks everybody.
Yeah, thank you. And I'll just tack on, thank you all for sitting in a very warm room on a Thursday afternoon. Thank you for being here. Anybody have any questions?
So maybe let me just say I love the contributing guidelines for the wiki.
What was that?
I love the contribution
thank
guidelines
you.
for the wiki.
Thank you.
It's not a hard question, but I'm just wondering why Dirk Jan's name is before the stories.
I don't know. I don't know. I don't know.
You can take that one, yeah.
We can let them fight it out. We'll fix it. And we did want to call out just a whole bunch of different people. As Thomas said, these are people that inspired us, but also created a lot of the techniques that we talked about today. We did create some of the stuff that was up there and write tooling around it. A lot of the initial ideas were based off of things that these people contributed. So a huge round of applause for all of those folks. Super helpful. Thank you.